Thank you everyone for coming today. It is really gives me great pleasure to be with you. So I even put on a nice tie because, you know, with COVID-19, we didn't have lots of meetings. So usually I just meet with myself these days. So today I decided to put a proper tie so that you can say this is a real professor. Although don't worry, you know, about the professor and the titles and all of that. I'm just gonna talk to you in essentially just have a conversation about, you know, your interests, and feel free to jump in and give me as many questions or feedback as possible. So I understand you're studying, you know, a course and it's organized. You know, marine science and maritime studies. So I'm sure there's a lot of interest there. But what I want to add to your, you know, discussion, if you will, or conversation, is a little bit broader, and the idea that everything that we do in marine science is connected to society. And I think that's really an important thing, because most of the time students ask me, well, why, I mean, at the university, they say, why do we have to do all this complicated maths? But we're studying marine stuff, or we're studying environmental engineering, we're studying all these things. And I give them that opportunity to actually understand why it is connected. So, and some of the stories that I'm going to tell you today may surprise you. And this is essentially the kind of work that we do at the university, is that we are actually investigating all sorts of things that are within the context of marine or estuarine or freshwater. The first thing that I want to say is that, as you probably have seen in a bit of a negative way with this crisis that we're living in, is that with COVID-19, I think we realize that the world is connected in very, very complex ways. So that's a bit of the negative thing, because, you know, we're connected too much, I think, economically, we're connected too much in terms of supply chain. And then at some stage we couldn't find certain things because places that produce those things were not working and all of that. So we realized suddenly that the world is connected. So there's a good thing about it and there's a bad thing about it. Now, in the environmental world, connection is actually only a positive thing. All right. So the ocean doesn't live by itself. The ocean is connected to everything that you do in your daily life. Even if you are actually living away from the ocean, everything that you do impacts the major elements that are surrounding us: water, the environment, land, and all of that. So I like to broaden this conversation by introducing you to one of my favorite frameworks. And just with the show of hand, if you can tell me how many of you have heard about, let me just bring my favorite flag. Have you heard about the Sustainable Development Goals? Yes? Show of hand. You know this one, Sustainable Development Goals, right? So you probably have seen them around. This is really an important framework that stresses the connectivity that we have in the world. And that's why you're going to see in what you study in marine science, everything that you study in marine science has implication for these 17 goals that we want to achieve by 2030. Now, that's really important, because if we take marine science, and I take this, one of my favorite cubes here, and we look at this goal, which is life below water. So suddenly you say, okay, why do we care about marine science? Why do we have to study how the chemistry, the biology, and the physics interact together to create a habitat, to produce resources? All right, so that's the most immediate connection to what you do, which is life below water. Now, the other thing that you can think about is, next one here is about climate action. right? So the connection, why marine science and how the ocean and what does the ocean play? What's the kind of role that it play in moderating the climate? If someone tells me what is the number one job of the ocean, I would say the ocean has thousands of jobs, but I think the number one job is moderating the climate, is driving the climate. You've seen the storm. Have you received the storm? Was very strong, right? That's when you realize that the ocean is the boss. You can see it. It's one of my favorite things is to go to the ocean, to the beach, when it's really stormy, because I think it's boring when you go to the beach and there is no waves. It's really boring. But when it's really stormy, that's when you see the amount of energy that's being circulated. So that's one of these things that I want to share with you. So I'll take this box, just throw it away, and I'm going to look for another one that is important. So what does the ocean do to this other goal, which is number 15, which is life on land? Because the ocean drives the water cycle, the ocean drives the climate, and if there is no ocean, there is no life on land. That's really as simple as that. And that's really the fundamental thing that lots of the times we spend time trying to break our head and like do lots of complicated maths, but we don't stop to think about the simple things. And for me, it's about the connections. It's about why does it matter and why should we care? Now, I wanted to introduce these Sustainable Development Goals because this is a world that got together through the United Nations and decided that by 2030, we should make a big step of achieving these 17 goals. 17 goals. So they are very specific. You can hop on the United Nations website, and you can see all the details because they have sections and all of that. But what I want you today is just to reflect on this idea of what am I doing personally to contribute to these things. So obviously, the other thing that you can see, one of my favorite things, because I'm an educator, you see, quality education is number 4. This is absolutely essential. That's why you can't do anything without education. You can't do anything without learning about the processes that drive the ocean, that moderates the ocean, the social implications of the ocean, the issues around peace and justice and fairness and maritime movement and slavery that happens in lots of places around the world that is actually within the ocean. So there's lots of things that go in the ocean that have implication on other social things that we don't think about, that justice and things like that. So it's really important for me to broaden this conversation a little bit more. And then let me just introduce you to one of my projects. Can you see? Can someone tell me whether you can see the screen?
Yeah, we can see that. All good.
All right. So here's another one that I want to introduce to you. And you have heard, obviously, of persistent pollutants, everyone? Yeah? So persistent pollutants are pollutants that once they are in the environment, it's very hard to get rid of. Yes? So that's the simple definition. So one of them is, surprisingly, glitter. How many of you know glitter? Show of hands, how many of you like glitter? So, me too. I have my daughters there, when they have like their birthday parties, it takes me about 4 years to vacuum the carpet and to get rid of the glitter from everywhere. I still find glitter from last year's parties. It's persistent in my home, but it is really surprisingly persistent in the environment. So let me tell you about the story of glitter and what we've done in my research And this is something that went around the world. Lots of people said about me that I'm a professor who calls for the ban on glitter. And I received lots of hate mail from people saying, why do you want glitter to be stopped? I said, no, don't worry. I don't want glitter to be banned. I want plastic glitter to be replaced by biodegradable glitter. So you can still have glitter, but it's made out of something that is not plastic. Now you see how tiny glitter is. I'm sure you know, all of you, how tiny is glitter. So the research that we've done is that we asked the question, we said, where can we find glitter if we follow glitter around the water cycle? Meaning from your house, you take a shower. If you have glitter, it goes into the waste treatment. From the waste treatment, it gets treated, and the water, in some cases, get discharged, even treated, gets discharged into the ocean. And this is when you see the connectivity come in. You can go to the beach. If you have glitter on you, it will end up on the beach and whatever. So we said to my team, well, let's go and see whether we can identify glitter. Now, how do you do that? You take basically samples from everywhere, and we apply some really advanced technology, and we take the particle and we bombard it with a very, very, very warm light. So the particle gets basically bombarded with this very warm light, and we vaporize it, and we can tell it's glitter. Not only we can tell it's glitter, we can tell what kind of glitter it is. Now, this is really something that surprised everyone, because people were like, oh, you're not going to find some. The problem is, as predicted, it's a persistent pollutant. If you're looking for persistent pollutant in the environment, I can guarantee you that everywhere you will look, you will find more than you expected to find. So we found essentially glitter everywhere. And that started a movement where people started going like, oh, this is something we need to pay attention to. Now, why glitter is interesting? Because glitter attracts attention, and lots of, even top models decided that they're going to take an action and not use glitter that is made out of plastic or metal, because some of it is made out of metal. And, my research was actually published sometimes in fashion magazines. So I really tease my colleagues, and I said to them, your research only gets published in scientific journals, but mine gets published in very, very fancy elite daily magazines and fashion magazines. So that's really important. So that means what? It means that science is really popular and science is really fun, and understanding how pollutants go through the environment is exceptionally useful. And that's why, for me, it's not just about marine science, it's not just about physics, it's not just about maths, it's not just about HAS, it's not about social, it's about the integration. And that's why I'm introducing you to my favorite topic. Remember here, everyone is going to promise me that you're going to hop on the United website and look for this, sustainable development goals. And what I want you to do is I want you just to adopt one of these. Like maybe over a day, every day, you can decide to adopt one of these goals and do one action, only one action that you think contributes to one of these goals. All right? This is a way for me to connect you with actually the reason why we study and we spend lots of time doing lots of complicated research that requires lots of money, lots of resources. And our students at the university are really passionate about things that have impact. So that's why we're introducing these things. So, adopt things like this, and you will see there's a lots of benefits. Now, because I just like to do research that is fun. Well, this is not the only kind of research, but let me show you another one that we did, which is, I go to the next one here, share. Can you see this one? Yes, I presume you can see it. Yes, good. So you can see this one also. It's a really interesting study that I took part in with a number of colleagues, to support the Australian Federal Police, who wanted to know whether we can trace illicit drugs through wastewater systems. And you may have heard in the news that lots of research is happening at the moment to actually trace COVID-19 in wastewater. Now, this is extremely useful to know that the water cycle is completely connected, the ocean, to the water cycle. And in this case, what we did is preliminary studies where we release drugs from one site and we collect them in the other site. Why is this relevant and why is it important? It's important because, one, we can do it. From the technological point of view, we can actually measure anything in the water. So that means that we have a very, very advanced understanding of water. It's a fascinating area. The second thing is we can actually make predictions about how drugs are circulating in the community, and that's obviously has important social implications. It does help in terms of providing for services, in terms of understanding some of the new chemicals that get introduced illegally. Well, lots of these things are illegal, but the majority of these chemicals are known, but some of the chemicals that actually get introduced, some of them are extremely toxic. And that's how you see in some parties, people, lost their life in Australia, where young people took drugs that were basically new chemicals that were introduced in the market. So, the notion of connectedness and connectivity is extremely important. So really, for me, I don't want really to give you a formal lecture and to put you to sleep, but I want you just to start thinking about the connection between anything that you do. And if you look at that table of, you can actually download from the United Nations, you can download this whole table of United Sustainable Development Goals. And one of the things that I do is that I look at it and I see what are my activities as an individual, anything that I do every day, where does it impact negatively and where does it impact positively? And one of them is, you can think that the majority of our activity, what we do, we wake up in the morning, we take showers, so we use water. So that's one of the first things that you can think about. And there is a goal. There is a goal for that. It's number 6, and it's water and sanitation. So that's extremely important, water and wastewater. So the way you use water at home impacts the ocean, because it goes through this number 6. So I say, well, if I'm being bad, I put a cross. If I'm being good, I put a check that I'm being good about that one. So that's a really extremely useful way. This is not about guilt tripping people into not taking long showers, but do what you can to achieve those goals. And this is how, when you adopt a goal, you can actually pass that information. It helps you guide your learning. It helps you also understand your interest in future careers, whether you want to work in the social aspect, you want to work in the science aspect, you want to work in any other aspect. Now, surprisingly, you may have heard about this one, number 5. Yeah, this is a really important one. So this is something that everyone is trying to achieve: gender equality, to have balance in society. But when we connect this one to water, we find that actually in underdeveloped countries, every day there is an 8-year-old girl who walks 8 kilometers to fetch water for her family. We're talking about a girl, not a boy, because they make girls skip school to fetch water. So water access in the world is directly connected to this aim here. So this broad thinking that we're trying to encourage students to adopt has much, much more I suppose, rewarding outcomes when it comes to, you know, studying. So the ocean is boss, remember, that's number one. And the ocean drives everything that we do. And the ocean is connected to our everyday life in so many ways. And if you really want to, you know, develop your understanding and formalize and frame your learning, I really encourage you to think about sustainable development goals as a way of understanding the impact. You can do projects as well and map them against sustainable development goals. You know, that goes from individual activities to group activities to school activities to food and waste. If you have a chance, you can watch one of my TED Talks about water and chocolate. So it's called how to drive yourself out of a water shortage. And I talk about the link between food, that's another big topic, and water. And I think that's really, really extremely important because, again, we wake up every morning, we take a shower, next thing we do, we eat. So the things that you eat can influence the way the ocean works, can influence the way the environment works, can influence the way society works. So your decisions are extremely important as an individual, as a group, as a community, as society. And if we want to influence the world in a positive way, we have to think about the connections. So it's not just simply to say it's a good thing to adopt sustainability and sustainable development goals and protect the ocean. It's to understand why we want to protect the ocean and what's the best way that we can do it, both as an individual through our action, but also as groups. And I will stop there and I will take any questions that you may have about marine science, about environmental engineer, about engineering in general, about the world, anything. Glitter. All right, over to you. Who's moderating? The chat is not saying much. I didn't. Yeah, you can
right,
stand
yeah.
up and come. Yeah, please come to the mic.
Is it true that toxins enter the marine food web by attaching to persistent pollutants?
Yes, absolutely. That's you know, the notion that anything that actually is transported via water can either be transported in dissolved form, meaning inside the water, right? Dissolved, like sugar. You mix sugar in the water, you mix salt in the water, and it goes inside the water, right? There are some times where particles like microplastics can also absorb, meaning they can transport pollutant and other substances through you know, the marine life. So there's many ways of transporting. So anything that is particulate can actually transport persistent pollutants. Now the problem is that you know, small organisms like zooplankton, which is something that I study, can ingest. Sometimes they don't make a difference between a particle that is a microplastic and a particle that is an algae. So they ingest that and it goes to the food web because the fish will eat zooplankton and a bigger fish will eat small fish and bigger fish will eat smaller fish. And that's how the food web works. And that's really extremely important. Remember that for the ocean, we are at the top of the food chain as well and the food web. And that's really extremely concerning because anything that goes through the food webs in the ocean will end up on your plate in one way or the other. Good question. Any other questions? Please come forward. Any question, curious, you know, serious, non-serious, whatever. Just, it's really open. Who wants to be a marine scientist? Yes. Who wants to come to UWA?
Unmute. There you go.
Yes.
In WA,
Yeah.
what's the most damaging pollution issue?
Oh, look, relatively speaking, let me just say this. In Australia, in general, we have a relatively good environment in comparison to the rest of the world. That doesn't mean that we have to rest assured that there is no risk. So is our environment at risk? Yes. Are we worse off or better than, say, countries around us? We are much better. And the reason why we are much better is because we are educated, is because we have schools and we have high schools who are extremely good at educating students. And then the general publication is generally specifically educated about the environment. So you walk around and the environment is relatively clean. Now, however, because of the increase in population, and especially because of large cities like Sydney, Melbourne, and others, so we have less of that problem in WA, but in larger cities, we have all sorts of issues to do with stormwater that end up in the coast, that end up with a number of pollutants. So are we at risk from a large list of pollutants like PFAS? Have you heard of PFAS? This is a substance that was used in fire retardant, so that's a risk, that's a high risk one. Plastics is one of the pollutants that we are actually looking at very, very carefully. Heavy metals are present in our environment. If they are present in our environment, they will end up in the ocean. So, my assessment is that we are doing okay, but we need to be really careful about increasing population, increasing density. Discharge regulation is tough, so we don't like to discharge toxic stuff to the environment, but occasionally it happens. So I think we have good regulations. We just have to be vigilant. Good question. Anyone? Yes.
Is eutrophication getting better or worse in WA?
Yeah, absolutely. Great question. I think we have that under control. You will find that some systems like the Swan River, there's some of them down south as well, estuaries that have received a large amount of nutrients in the past. We see less of that. We see occasionally high risk of algal blooms and eutrophication. That's, you're referring to eutrophication as the growth, the sort of extraordinary growth of algae that is fueled by nutrients. We see less of it. And the reason being is that we have controls in place in terms of nutrient management at the catchment level. However, there are systems that occasionally will display anoxia. Have you heard of the word anoxia, which is lack of oxygen when the fish have not enough oxygen through the processes, biochemical processes that consume oxygen too fast, and the fish are left without oxygen. So we do see that in some systems in the Vass, for example. The Vass is one of the rivers that experience unusual levels. We know what causes those things, and there is action that's being. So to your question, is it getting better or worse? I think it's under control, but it means it needs to be watched. Yes, please come forward.
Why are there often bans on eating shellfish from certain places?
Yes, that's the reasons can be. What's your name?
Jacob.
Hi, Jacob. So there are many, many reasons for it. So it could be either a chemical pollution. that basically bioaccumulates inside shellfish, but it could be also algae. And sometimes we work on wastewater in places like Werribee in Melbourne, where oyster farming can be affected by discharge. So for example, if there is heavy rain, wastewater systems can overflow. And if they overflow to the environment, that overflow will end up in shellfish. So because shellfish has the tendency to absorb lots of particles from the water column. So these are measures that the government has to put in place to protect the public. So it's a public safety measure. Every time there is a risk, in general, if you ask me, in general, it's not too much of a high risk, but it is something that people have to follow the authorities when you have signs that says, well, it is recommended not to eat shellfish from a certain region. That's an indication that either there has been a discharge of a substance that the government is not comfortable with, or there has been a growth of eutrophication, like growth of algae that is toxic. Things like cyanobacteria can be toxic. Dinoflagellates can be, some of them can be toxic as well. And some of them can cause all sorts of illness and injury to humans and dogs. And so it's not just about shellfish, but it's even contact with the water that has toxic algae can be damaging to life. Now, shellfish has the tendency to accumulate. So if there is 1 milligrams of toxic in the water, inside the mussel, it will be 100 times, because the mussels will accumulate over a large period of time. All right, great question. Thank you. I have a question here. Yes, what's your name?
Hi, my name's Clyde.
Oh, hi, Clive.
What do you think is the biggest global issue our marine life is facing today?
Oh, man, that's a big question. Big global issue is overfishing. Overfishing. Big one. Where is my other thing? Oh, here you go. Enough said. Climate. Of course, people, overexploitation, pollution, but number one by far, the large scale, is overfishing and climate change. Is that enough?